So yesterday we started with the probability of compound events, and we say that the compound events is an event with more than one event. And to combine between two events or more, I can use two words, and or. And according to and or, I can classify the events into mutually exclusive events or overlapping events, independent and dependent events. We talked about the mutually exclusive and the overlapping. The mutually exclusive, that's there's no common outcomes between them. There's no common outcome. The overlapping, there's a common outcome. The formula of the mutually exclusive probability of A or B will be probability of A plus probability of B. But for the overlapping, since we have something common, we have to say the probability of A plus the probability of B minus the probability of A and B. For the mutually exclusive, I want to draw its Venn diagram. This is the probability of event A, and this is the probability of event B. There's no common things between them here. So I will say the probability of A plus the probability of B. But for the things that we have something in common, this area here show me the probability of A. This is here. Probability of A. And this area here is the probability of the circle here is the probability of B. So the probability of A is the blue, the probability of the event of the blue circle minus the probability of the event of the green circle, a plus, sorry. Now minus, if I told you now probability of A and B, I want the numbers of the event in this area here. This area here shows the probability of A and B. This is here the probability of overlapping events. So let's remember that if I have, so as I told you before, if I want now to combine between two events, I have to use, so if I have now two events, just a second, please. So if I have now two events, and I want to combine between them, I have to use or, and. A or B, A and B. Now, A or B, for the letters or, I can classify them into mutually and overlapping events. Now, for the and, I can classify them into independent and dependent events. Let's now take an example of or before going to talk about the independent and dependent. Here, suppose you roll a standard number cube. So what did we have here? What is the activity? What is the event? I roll a standard number cube. So what is the sample space of the number cube? As we know, what is the sample space will be? 1,
6, 1, 2, 3, 4, 5, 6.
4, 5, and 6. Then, what is the probability that you roll an even number or number less than 4? In lesson 7, I told you now what is the probability. If I asked you now, what is the probability of even number? Probability of even number. If I told you the questions come like, what is the probability that you roll an even number? You write it like this. And this is not a compound event. This is a simple event because I have only one event. I count how many even numbers we have. We have 3 numbers over how many all possible outcomes? They are 6. So I will say 3 over 6. This is here simple event. I have only one event. But now here, what did we have? Look at the question. What is the probability that you roll an even or number less than 4? So here, how many events we have? We have 2 events, even.
We have to carry even number, yes.
And less than 4. So I have here 2 events now. So I remember that if I have 2 events, what I have to do here? I have to say the probability of even number or number less than 4. Then here I will write the formula here now. Type the formula now. Since I see word or, so I want to classify now these events into 2 things. It could be mutually or overlapping. How can I know? Just ask yourself one question. Is there an even number and number less than 4 at the same time? Let's think about it. Number less than 4. Yes, there will be number 2. So I will say, yes, there is. So that means it is an overlapping. So what is the formula will be? Probability of, let's first clear here. So the answer will be the probability of even number plus the probability of number less than 4 minus the probability of even and less than 4. Then, what is the probability of even number? How many numbers are even here?
3 over 6.
3 numbers.
3
Yeah.
over 6.
So 3 over 6 plus how many numbers are less than 4? What are the
2
numbers
over
less than 4?
2 over 6. 5 and 6 are the only. Oh no,
less
1,
than,
2, and
less
3.
than.
3 over
1,
6.
2, and 3. Bravo. Less than 4, يعني 1, 2, 3. So we have 3 numbers over 6 outcomes. Minus now. I will ask myself now. We found that yes, there's a number that is even and less than 4. Which number? That is less than 4?
2.
And
Probability of 2.
2. Bravo. So how many outcome here?
1 over 6.
1 over 6.
I have only one number, so I will say 1 over 6. So then I will add 3 plus 3 is 6 minus 1, 5 over 6. Is it clear?
Yes, miss.
Okay. Now B. What is the probability that you roll a 2 or an odd number? So here let's write that the sample space 1, 2, 3, 4, 5, and 6. Now then, here, probability of rolling number 2 or odd number. Now remember, I have word or يعني mutually or not. So then I will write the formula here like probability of 2 plus probability of odd number minus probability of 2 and odd.
Teacher, how you know that it is odd number? I mean, يعني
هلا here طب okay, this one keep it later on. هلا first of all I want to give you another idea بس خلاص okay. Now here 2 are odd. هلا 2 when I see word or that's mean I could be mutually or overlapping. طيب how can I know if it is mutually or overlapping? By searching about common events. يعني I mean, is there a number that is odd number and 2 at the same time? يعني or before of that, here put a circle that contain number 2 and put a circle that have the odd numbers. What are the odd numbers? 1, 3, or 5?
yes.
Yes. So is there a common number here between them?
No.
There's no common number. So that's mean I am mutually no. Mutually means probability of A plus probability of B. Is it clear?
Yes.
Yes.
Now, probability of 2, how many 2 here in the sample space?
1/6.
1/6 plus. How many odd number? 3 numbers, yeah. 1 with 3
over
so with 3/6. So what's the final answer will be?
4/6. We will simplify it. No?
Eh?
Teacher, do we need to simplify it in 4/6?
Yeah, no, yeah, you can write it as 2/3, but if you keep it as 4/6, there's no problem.
Okay.
Teacher, don't remove it, just a minute.
يلا اوكي.
Teacher, this is got it 1B, right?
Sorry?
This is got it 1B.
Yeah, 1B.
Teacher, can you tell for got it 1A just a minute? Or you can't?
I cannot go back, sorry. Because I
Okay,
read
no.
a bit.
Okay, thank you, teacher.
Yeah. Now let's talk about if I have 2 events now and I want to combine them, but using word and. If I have to use word and, as I told you, like probability of event A and B, I will classify it now into dependent and independent. Now, what's the meaning of independent events? Independent events mean that the outcome of one event does not affect the outcome of the other event. Such as tossing a coin and rolling a number cube. If I choose head, it doesn't affect that if I choose number 6 on the number cube. Both of them are different events. Both of them have different outcome. So they are independent. They didn't depend on each other. This is the meaning of independent events. That the outcome for tossing a coin does not affect the outcome of rolling a number. This is a thing, and this is another thing. This is the meaning independent. How the formula will be? Probability of A and B will be probability of A times the probability of B. Remember, as I told you before, and it's mean multiply. So if the two events are independent, the occurrence of the first event didn't depend or didn't affect the occurrence of the second event, I have to say that it is the probability of A times probability of B. There's no relation between them. Tossing a coin and rolling a number cube. Choosing your favorite subject and tossing a coin. If I choose that my favorite subject is science, and I toss a coin and the outcome is head, is there a relation between them?
Again,
As an example, two events. One of them, I asked you, what is your favorite subject? And the second event, tossing a coin.
yes,
Is there a relation between them?
no,
Okay, does it mean if I choose head, that's mean I like science? Or if I choose tail, that's mean I like math?
no,
No, they are independent events. If I choose science or if I choose English as an example, it doesn't affect that I choosing head or tail. So they are independent. The formula of the independence, that probability of A times probability of B. Let's have now an example to understand. Here now, what did you see? You see two number cubes. One of them is blue and the other is red. I roll now the two cubes at the same time. Now ask yourself, if I have number 2 on the blue number cube, does it affect that I must choose number 3 on the red number cube? If I choose number 1 on the blue, does it mean that I cannot choose number 1 on the red?
not teacher, maybe.
Maybe I can take one from the blue and one from the red. And if I choose one on the blue, doesn't mean that I cannot choose one on the red. They are independent. So here now, you suppose you roll a red number cube and blue number cube. What is the probability that you roll 3 on the red cube and even on the blue cube? So this is an event A and this is an event B. Now, probability, how I see it. Look at here, what did we have? Word and. Word and means probability of A and B. The first question here, since we have at, so don't think about mutually or not mutually, or sorry, mutually or overlapping. Don't think about it. And it's mean dependent or independent events. Now, then ask yourself, if I choose number 2 from the blue, and then I choose number 3 from the red, does it affect each other? You say no.
No.
No, it's mean it's independent. Hello, what is the dependent? Dependent mean I choose number 2 from the cube, then I will choose number 3 from the cube, from the same cube. This will be dependent. But if I have 2 different cubes, I will say that it's independent. Later on, we will talk about the dependent. So here we have 2 number cubes. The first one, what is the probability that I get number 3 on the red cube?
1/6.
Bravo. For the red here, what is the outcomes? 1, 2, 3, 4, 5, and 6. And I
Yes.
get number 3. So how many number 3 here on the red cube?
1 over
1.
6.
1 over 6. Bravo. Plus and
Yes.
it's mean multiply. Then probability of B. Where is event B? B, it's mean I have to see how many numbers are even here. I will go now to the blue number cube. How many numbers are even here? What are the even numbers from 1 to 6?
2, 4, 6.
2, 4, 6. So how many numbers? They are 3 over 6. We have 3 numbers, so I will write it as a 3 over 6. Then when you want to multiply, don't forget, in multiplication, you have to multiply both of the numerators and the denominator. It's a 3 over 36. Is it clear?
Yes, miss.
The others, miss, do you have any question?
No, teacher.
No, teacher, thank you.
Yeah.
No, teacher.
Now here, in Gutted 2, you have a red number cube and a blue number cube. What is the probability that you roll a 5 on a red cube and 1 or 2 on the blue cube? So now here, probability of roll 5 on red and roll 1 or 2 on the blue. This is an event A, and this is here an event B. So the answer will be the probability of roll 5 on red times probability of roll 1 or 2 on blue. Hella, what is the probability that you roll 5 on red? Now look at the number cube. For the number cube, for the red number cube, we know that the outcomes are 1, 2, 3, 4, 5, and 6. Now, you roll 5. So how many 5 here we have?
1.
1, 5. Is it right? Thank you. 1 over. How many possible outcomes?
6.
6 times probability of rolling 1 or 2 on the blue. 1 or 2
over 6.
How many numbers? They are 1 and 2. So we have 2 numbers over 6, which is 2 over 36. Is it clear?
Yes,
Yes,
teacher. Can't move it just a minute.
Okay.
Okay, finished. Thank you, teacher.
Okay. All right. Now, let's go to talk about the dependent event. Dependent means that if the outcome of one event affects the outcome of the another, that means they are dependent events. Here, يعني, what does it mean? Like, if you have now, if I ask you a question, what is your favorite subject? And what is your favorite color? Now think about them. What is your favorite subject and your favorite color? Are they, or are the events or the outcome of the favorite subject depends on the outcome of the favorite color?
No, teacher, they are independent
They are
events.
independent. يعني as an example, Farah, what is your favorite subject?
Science,
Science. And your favorite color?
pink.
Pink. So when Farah chooses the science, it doesn't affect that she will choose pink or red, her favorite color. This is here an independent. But if I told you now you have 5 subjects here: science, math, French, English, and Arabic. And then if I asked now 5 girls, let's start now with Farah. Farah, she said that I prefer science. Now, because Farah, she chose the science, so I will remove the book. I will say, خلاص, okay, Farah choose science. I will remove the science now. Then, and if I go now to Basmala, Basmala, which is your favorite subject? From here.
Favorite subject, math.
Math. So now she choose math. So then I will remove math. Then Huda, from the remaining here, French, English, or Arabic, what's your favorite subject?
English.
English. So now, Huda, when she chose English,
Yes, miss.
when she chose the English, Huda now here, the outcome of Huda depends of the outcomes of Basmala and Farah. Because when Huda come, she said that there's nothing here. I will choose English because science and math are left. So the outcome of Huda depends on the outcome of Farah and Basmala. And the outcome maybe Basmala like science. She didn't like math. But science is not written or is not here because Farah, she already took it. So the outcome of Farah, of Basmala now depend on the outcome of Farah. So it means that this will be a dependent events. So the dependent events mean that the outcome of the one of event depends on the outcome of the second event. Let's now talk another example. Or let's take another example, sorry. Here now you have a marble, you have a box as an example, and inside this box we have many marbles. Inside this box here, what did we have? We have 5 yellow, 3 purple, 3 violet, 4 blue, and 5 pink. So we have now 20 marbles as an example. Now let's draw them here. In order to understand, please, all of you, be careful and focus with me. Here now we have a jar, and inside the jar we have a marbles. They are equally likely. I mean like they have the same size. Now, here now, as you see, we have a lot of marbles. Let's see now here. How many pink marbles we have?
3.
3.
We have 3 pink. How many red?
4.
1, 2, 3, 4, 5. We have 5 red. How many green? 2 green.
2.
Bravo. And how many blue?
2.
2.
Blue. And then what other colors we have? And orange. How
Orange.
many orange we have?
3.
3 orange. So now here, as we see, we count how many marbles we have in the box. We have 3 pink, 5 red, 2 green, 2 blue, and 3 orange. Okay. Here now we have this is here the questions like, what is the probability that you have or you choose a red, then yellow? There's no yellow. Red, then pink. Now, the probability now, if I told you now, probability of red, then pink, here words then, it's mean and. يعني probability of A and B. But this then means here, if I choose the red, I will not replace it. يعني, first here, you have to say that the probability of red, then pink. It is the probability of red times the probability of the pink after you choose the red.
What pink?
Means like, here now, what does it I mean? I means like probability of red, then pink. Yani, what is the probability here of getting red? What you have to say? You have to say
over
how many red here?
5.
5. How many marbles in the box?
15.
5 plus 3, 8 plus 2, 10 plus 15. Bravo. We have 5 over 15. Now, after I choose the red, I will now take it outside. As I choose it. So I will take it here outside now. Right, times now. What is the probability of getting pink? Now, how many pink here we have?
3 over 15.
3. No, wait. I took the red. So since I took the red, so how many marbles do we have now?
I is 10.
They will be 14 now. I choose the red. I take one of the red outside now.
Teacher, one of the red or 5?
Now, see, for the probability of red, I say that we have 5 red. So I will say 5 from the whole marbles, what they are 15. Now I get one of the red. I get 1. I didn't take the 5. I take only 1. So after I take one of the red, I keep it now outside here. So how many marbles we have now in the box? We have 14. And how many pink we have? We have 3. So the probability now of getting pink after I take the red outside the box is 3 over 14. This is here means that they are dependent. Why they are dependent? Because the numbers of the marbles here after I choose the red is changed. The number of the marbles here depends on the how many red cubes I have before. Or how many, how many marbles I took. Let's take another example now. Probability. Now let's come back. Let's bring the marble, the red marble now back here. Now, the probability of choosing blue, then orange, then green. Look here. Yeah, let's start now with the blue. The probability of getting blue. How many blue here we have?
2 blue.
2 blue. Over how many marbles? 15.
15.
So what did I get now? I choose the blue. I have to choose now 3 marbles. The first one is blue, the second one is orange, and the third one is green. So for the first one, I choose the blue. So now let's put it now outside the box. So here they ask me, please come here, choose 3 marbles, blue, orange, or green. So they tell me now, okay, blue, I took the blue. Fine. Then now I want you now to choose the green, the orange, then the orange, sorry. Like the orange. How many orange here we have?
3.
3 over 15.
لا ما هو
Over
say
40.
choose. I take the blue now outside the box. So how many marbles here we have?
14.
14 now. Then I choose now the green. After I choose the orange, I take it now. I took orange. So I take it now out of the box. Then green. How many greens we have? We have 2.
2.
How many
2
marbles now
over
we have?
13.
13.
Bravo. Over 13.